So today we're going to look at 8.2 transformations of logarithmic functions. This is outcome R9. Now R9 says graph and analyze exponential and logarithmic functions. So that's what we're going to do. Okay, so yesterday we looked at exponential and logarithmic functions, right? And we noticed that these two are inverses of each other. So what we're going to do is we're going to graph both of these on the same grid and just kind of have a look at what we've got. So if we want to do a quick table of values just so that we can keep our points organized. So let's say this is x and this is our y equals 3x here. So I'm going to choose the points 2, -2, -1, 0, 1, and 2. So if I have -2 here, if I've got 3 to the power of -2, that gives me 1/9. The negative in the exponents makes it go into a fraction, right? Remember that? And then this is going to be 3 to the power of -1, which is 1/3. 3 to the power of 0 is 1. 1, so 3 to the power of 1 is 3, and 3 to the power of 2 is 9. Okay, so let's plot these points here. So -2 and 1/9, that's super close to the x-axis. -1, I've got a third, so that's, let's say this is halfway, so that's a third. So we're just estimating where that is. And then here for this one, 0, it's going to be at 1. And then my x equals 1, I have 3. And 2, this is going to be way off the charts up here, and 9, right? Okay, so let's join these with a nice curve. Have arrowheads there. Now, what else can you tell me about the graph of this? What else do I need to note? I need to note an asymptote here. So I indicate that by a dotted line extending beyond the axis that's drawn. And the reason I do that is because it's hard to see the asymptote if I draw it directly on here, okay? So we want to extend it a little bit. So this is y equals 0. Okay, so now let's do the log equation. So I'm just going to label this one here so we know what we're looking at. Okay, now the log one, let's see, we've got y equals log base 3x, and then a little table of values. So notice that they're inverses of each other. So what I'm going to do is I'm going to choose my x values so that they are these y values here. So instead of, so my x value I'm going to choose as my 9. So what do I get as my y value? I get 2. So if I choose 3 here, what do I get for 1? And then 1 I get. And then if I have 1/3, I get -1 and 1/9. You can't even see what I'm writing. You get -2. Okay, so where does this end up right here? We could just look at the graph and know that all of my x and y values are going to be switched, right? Because it's inverse. So my 9 is going to be way off the charts over here, off my graph. I can't see it, so let's bring it back to 3. So at x equals 3, I have y equals 1. And then, so x equals 1, I have 0. X equals a third, I have -1, so that's about here. -2 is going to be where my x is 1/9. And I'm going to have my graph going like this. Yeah, asymptote at x equals 0, so let's extend it here, right? X equals 0, and extend it at the top as well. That's where x equals 0, okay? So let's label this. So this is the inverse of y equals 3 to the power of x, so I could write it as y equals log 3x. Okay, so just a note on the bottom here is the graph of y equals log base 3x has a vertical asymptote at x equals 0 because x has to be greater than 0. So x is greater than 0 is a restriction of the argument. So that means this value right here has to be positive. Okay?
Which value has to be positive?
The argument right here. So this x, yeah, that number right there, the big one. Okay, so if we look at example 2, it says sketch the graphs of the following functions on the same Cartesian plane. And what we're going to notice is we're going to try to notice something special about the base. And yes, again, it is all about the base. Okay. All right, so here, for this one right here, where are we going to graph this? What do we note is going to be our... So they all have an x-intercept at 1, 0. Okay? So for this one here, we end up with x equals 2 and y equals 1. So it's based on the base, essentially, right? And then where is the point at -1 going to be? Where do you think it's going to be? At a half. So it's going to be right here. So this is, make that, so we could draw our sketch here. Okay. So we'll label that graph A. Now for B, where is the main point, where is the important point going to be over here? It's going to be at 4 and 1. So since it's base 4, that's where it's going to be.
Wait, for A, you said -1 is going to equal half, right?
So this is a half, yeah. So that's, it might not look like a half. X is a half here at y equals -1.
Oh, okay.
Okay, so a half and then -1 right there. Okay, so this is 2, 1, that point right there. So for this part B, where is that going to be? We're going to have a point at 4, 1. So 4, 1, so that's right here. So also 1, 0, yeah, so they're all going to go through there. And then where is B going to go through here? It's going to, at a quarter, yeah, so that's going to be a quarter. It's kind of hard to label that small, but all right. So have that graph there. And so that's B. And now for this one here, where is our main point going to be? What do you remember about what it has when there's no base written here?
10.
No base, invisible base. Invisible base equals 10. So I can write that as y equals log 10x. So then I'm going to have a point at 10, 1. So let's extend this. So 9 is here, 10 is here, so then that's going to be at 10, 1. And then, yeah, so, and this gets super close at like 0.1. So, and it goes again through my 1, 0. And then it's almost going to look like, a straight line, but not quite. And then it's going to come down here. Okay. So you could quickly draw these graphs just based on what the base is of each of these logs. Okay? All right. So just a quick note. So all of these graphs pass through 0.10. The base of the logarithm determines the next point. So the next point, so if it's base 2, we saw that it was at 2, 1. Base 4, so it's 4, 1. Base 10, it's 10, 1. So, and the reason why is if we switch this to exponential form, it's what we're looking for. So this is we've got the x value here and the y value there. So x value corresponds with the y values there to get 1, right? Okay. Awesome? Okay, awesome. Awesome sauce. Okay, now next one says, sketch the graph of the function y equals log 5, and then it's got x plus 2 in brackets and then a minus 1. Well, yeah, exactly. Left 2, down 1. So this is a trip back to what chapter? Yeah, left 2, down 1. You got to know that chapter super well. Super well, right? Okay, so first, what's our parent function in this case then? So yeah, our parent function is log 5x. So what's the point that we're going to plot? 5 and 1. Okay, so let's kind of just do a little sketchy sketch of that, right? So 5 and 1 is going to be 5 and 1. That's there. And then where does the point always go through? 0, 1, 0. So I've got 1, 0 there. This isn't much of a straight line, but you get the idea. Let's see, what else? What else? So this is going to be at like 1/5, right? Okay, so now I need to move every point 2 units to the left and 1 unit down. So for these fraction guys, let's just kind of, do it one at a time, and it's going to end up right there. I'm going to put an X there so I know that's where I'm going. And then this is going to go 1, 2 to the left, and this is going to go 1, 2 to the left. Now I have to move 1 unit down. So I haven't moved down yet, right? So down 1 to everything. So now I'm at my circles. So let's make sure we follow the pattern of what we need. It's going to go through, right there. Okay, so where has my asymptote moved to now? X equals -2. So I'm going to get a ruler to draw this down here. Okay, so this is x equals -2. And I think we're good. Let's label a couple of points so that we have them. 3, 0. Where's this point? -1, -1. And what is the value of this point here? -1 and 4/5. -1 and 4/5 and -2. Okay, beauty. Beauty. So next we have to state the domain. And we have to determine the y-intercept. Okay, so now the domain for this is, what are the x values that are allowed here? So I'm allowed, x can be greater than -2. Is x going to be equal to -2 ever? No, it'll approach it very close, but it'll never get to it. Or I could also write it in this notation here. So circle bracket, -2, all the way to infinity, round bracket I should have said. I said circle bracket. It's not square bracket because it's not including. Okay, so it never touches. So it's the same. So, and then it goes to positive infinity. So this is the -2 that it approaches. This is a -2 that it approaches, and then it goes out to positive infinity. It can never actually get to infinity, so we leave it as a round bracket. Okay. Okay. So log, so now I want you to note this over here. So we've got our logarithm, what do we know about this number in here? It
X value.
must be positive. Okay? Now, the number in here has to be positive. So if anything is going to make this number negative in this bracket, then that's not allowed. It's not going to work, right? We're going to get errors and stuff. So we could also think of it this way, and x is greater than -2 if you wanted an algebraic approach to it. All right? So we could just look at it and think of it. We could just look at it and think of it, or we could kind of run it through this algebraic approach. Okay.
Let's see, like x negative 1 can go in there, that's not much.
It doesn't have to be positive. We could put x equals -1 in here, and we'll get out a 1. We'll get a positive number. So that's okay. All right. Now, determine the y-intercept. What do you know about y-intercept? What's the condition that it must hold? X must be 0, okay? So in this equation here, we need to set x equal to 0. Okay, so we end up with y equals log 5, 2, and then -1. Okay, so this part you need to figure out independently. So if you don't have a calculator accessible, then this is what you will do. You will leave it here. Okay, if you have a calculator accessible, then you can go through and figure it out. You know what? Some calculators are coming out with being able to plug in, like some calculators actually will have a little box here and a box here, and then you could enter it in. If your calculator does not have that, what you have to do is go log 2 over log 5. So if your calculator does not have this function, then you have to type it in like this. You have to go log 2 over log 5, and it'll be the same bases. You have to change, you're basically, it's a change of base theorem, and we'll get more into that in the next lesson, but that's how you would type it into your calculator, and you get approximately 0.43. Okay? So you go y equals 0.43 minus 1, and then that equals negative 0.569. So I'm just going to round it to 0.57. Okay? So I'm just going to write over here on the side so it looks cleaner. Y-intercept is negative 0.57. Or you could write it as a point, which is going to be x equals 0 and negative 0.57. Okay? All right. So give that a try on your calculator. And then I think there's one more example. Okay, let's do it. So what do you notice about the equation that we have here for example 4? It looks a little wonky. It's a little rearranged. Okay, what do you notice about this here? What do you have to do? It's switched around, right? So you need to switch it around and you need to factor it. So we want to rearrange 3 minus x so that it looks like x plus, negative x plus 3. And then actually factor that negative out. So it's negative x minus 3. And now we can deal with it properly. So what does this mean? This is going, so this is, where is it going to reflect? This is a reflection, right? Reflect over, who is it going to affect? So here, let me write the rest of the equation here so you can see who it's affecting. So we're going to reflect over the y-axis. Yeah, so it's going to affect the, so that means it's going to go from here to here. Okay, and then this means that we are going right 3 And then what does this mean here? Up 1. Okay, so let's graph our parent function and then see where we end up going with this. So what's our parent function then? Our parent function, yeah, it will, because we have 3, 1, right? And then we have 1, and then this is at 1/3? Okay. So what are we going to do now with all of these points? So let's flip it. So I'm going to put 1s where I'm flipping, because that's the first move I'm doing. Okay. And then what should I do next? So I've reflected over the y-axis. This is done. What do I do now? Should I go right 3? Yeah. Okay, so which direction is right? This way? Yeah. Okay. I'm going to go 1, 2, 3. So I'm going to put a little 2 here. Then this is going to go 1, 2, 3. I'll put a little 2 here because that's my second move. And then this one here, 1, and then 2, and then 3. So what happened to my asymptote now? Where is it? It was here. I'm going to move it was on my y-axis. Now it's going to be right here. So let's draw that in right now before we forget about it. Okay, so this is x equals 3. That's the asymptote. And now, am I done or do I still have another move to go? I have to go up 1 unit now. So I'm going to put a star where I'm finishing. So I'm going to move this up here. I'm going to put this up here. I'm going to, where's my other 2? Move it up 1 unit. So it's going to go there. All right, so now we just connect it. Connect the dots. I'm just going to turn this over. Yeah. So here it was positive 1/3. Here it was negative 1/3, right? And then here it moves over 3. So it's 1/3 less than 3. Okay, so let's label this point here, which is 0, 3. This point here is 2, 1. And this point is where? The first point? Oh, sorry, that's 0, 2. Thank you. Okay, 0, 2. All right, now I'd like to erase the rest of the stuff just so that, it's not, there's no confusion that those are number points labeled or anything. Maybe I should have done them with. Okay. All right. 8/3. So 9/3 would be 3, right? So that's 1/3 less. All right. So 8/3 and 0. Beautiful. Excellent. Awesome. Okay. Yeah, 2 and 2/3, same thing. Okay. Now, domain. So let's look at the characteristics of this graph. What is the domain of the graph that I have? So I've got x could be less than 3, or I could write it as -∞ to 3. Right, not including either ends, right? And now what's my range here? So infinity, -∞ to infinity. To infinity and beyond, right? Or y equals the element of the reals. Okay, so I could either have it in set notation or interval notation. Yep, it's your choice. All right, now For the x-intercept, what do we know about the x-intercept? That is when y equals 0. Okay, so y equals 0. 0 equals log 3. So if I'm doing it algebraically, this is the equation that I'm setting up, right? And we know the answer. We know the answer is 8/3 because that's what we've graphed, right? So I was just going to show it to you algebraically. Do you not want me to?
No, it's all good. Yeah, I do it.
Yeah? Okay. All right. Then I will continue. So log 3 and then 3 minus x. So all I've done is subtract 1 on both sides, right? Now let's convert this so that I have it in which form? So yeah, let's switch it around to exponential form. So what does it become? 3 to the negative 1 equals 3 minus x. Okay, so now I'm going to solve for x. So I've got 3 minus 1 minus 3 equals negative x. So what is this here? This is 1/3 minus 3 equals negative x. So what does this become here? Negative 2 and 2/3 equals negative x. Well, can I just divide both sides by negative 1 and end up with 2 and 2/3? So that's my x-intercept. Now, since I've eaten up the room for my y-intercept, I'm going to do y-intercept over here.
Chris, what do you want to do?
Okay.
What do you want to do?
Okay, so now here I've got my y-intercept. What do we have to remember for y-intercept? What do we do? Set x equal to 0. Okay, now I've got y equals log 3, 3 plus 1. What's log 3 of 3? Right here, this is 1. 1 plus 1 is 2. What is my y-intercept? Does it jive with what my graph had? Yes, it jives. Okay, so for those of you folks who don't know what the word jive means, in my world it means, does it concur? Okay, so yes it does. It agrees. It goes with. And what's the equation of the asymptote? X equals 3. Awesome. Done. So make sure you do your homework. All right. Oh, and I'm so excited about the next one. 8.3, laws of logs, my fave. Log laws. Log, log, log.